All right, some test-inspired warm-ups. If you're watching at home, press pause, try these two, and then come back to us. So algebra first, natural log of e, that cancels each other out. Or I saw some of you even write out that the sine x can come down front. And that's great, especially if you remember that the natural log of e is 1. I still haven't done calculus yet, but that algebra has now made my calculus life pretty easy. dy dx is cosine of x. So pretty straightforward on that one. Number 2, find f prime if f is equal to natural log. Well, natural log is 1 over the dude times the derivative of the dude. So 2x squared plus 4x in the denominator. And the numerator would be the derivative of that thing, 4x plus 4. And you could leave it like that. That one you could divide everybody by 2. So potentially on a multiple choice test, it might be 2x plus 2 over x squared plus 2x. But I think you could make it from there to there, probably just by inspection, by just looking at your answer choices and realizing what they'd done. Questions on either of those two? Okay, get a little bit harder here. Or a little harder and then a lot harder, really. So number 3, that's find a second derivative. So that's not too bad. Just find a derivative and then find it again. You have to be careful on the second one, though. And then this fourth one, be careful. This tells you f prime, gives you g of x, and then asks for g prime. So see if you can piece that one together, and then we'll go over that one. Again, test inspired. I almost took number 4 off the test. Then when I realized it was on the warm-up, so I was like, oh, we'll leave it on the test because they'll have learned it and they'll know it. That's the thought process anyway. Number 3, we should be okay. dy dx, e to something, the derivative is e to the same thing, times chain rule, 3x squared. There we go. So that's the first derivative, but be careful, it asks me for the second derivative. So I need to do this again. This one looks a little complicated, so I don't think I want to just product rule in place. I want to write the pieces out. F prime, especially when e is involved, since you constantly keep doing e to the x cubed times 3x squared. That's f prime. G prime is 6x. So second derivative would be, the order doesn't matter since it's multiplication. F first times derivative of the second. So e to the x cubed times g prime plus, if it helps to connect them, plus the other way around, g f prime. So that would be 9x to the 4th. Yeah, 9x to the 4th e to the x cubed. Straightforward problem like that is probably a multiple choice question, which means they would do some simplifying. I could definitely take out an e to the x cubed. I could take out an x, and I could take out a 3. So let's see what that leaves us with. So on the first term, I took the x, I took the e to the x cubed, divided by 3, that only left 2. The second term, 9 divided by 3 is 3. There were 4 x's, I took one of them, so that leaves x cubed. And we took the e to the x cubed. So there's the simplified answer, likely the multiple choice answer. Again, free response, this one would be fine, except that on most of the problems that are straightforward like that, it's multiple choice. All right, number 4. F prime equals that mess of a thing. G equals this. Find G prime. Well, let's first find G prime, and then we'll worry about plugging 3 in, see what happens. So this is a chain rule. I'll do F prime of x squared minus 5, because I only do one layer at a time. The outer layer was the F. I don't know F prime. Actually, I do know F prime. That's why they gave me that. Chain rule, though, times 2x. So G prime of 3 means F prime of, let's see, I'm plugging in 3. 3 squared minus 5 times 2 times 3 is 6. Right? Because that just means wherever there was an x, we put in 3. So F prime of 4 times 6. And then now I understand why they gave me this mess, because they wanted me to find F prime at 4. So F prime at 4 looks terrible, but I think it turns out to really not be all that bad. Plug in 4 for x everywhere. There's the nice one. 4 minus 3 is 1. 1 squared is 1. 4 plus 2 is 6. Over 3 is 2. So F prime of 4 is 2. And 2 times 6 is 12. So that's a little bit of a tricky one because of chain rule. There's a hidden chain rule problem in there. And they start by giving you this thing, like, what am I supposed to do with that? And you're like, well, nothing for a little bit, and then you realize you need it, and then they've given you what you need. So that looked terrible, but you didn't need to, it is the derivative. You didn't need to take a derivative of it. So as bad as it was, you got to use it as it is. You got to change anything like it. Again, I remember specifically questions very similar to both of those are on the test. All right, let's try. Oh, we can fit all 3 of those on there. Try those 3. All right, again, you're watching at home, press pause, give them a go, and then come back and watch me do them. Test inspired, can't say that enough. I was just looking through the test to give you a word what's on it. Some very similar problems. All right, find dy dx at 1, 1. Okay, that's sort of the last step, is plugging in 1, 1. Let's find dy dx, and then we'll worry about plugging in the point. Natural log, so that's 1 over whatever we're taking the derivative of, times the derivative of xy. So that would be, here I will do it in place. I saw some of you doing this one in place. The first times derivative of the second plus second times the derivative of the first, but the derivative of x is just 1. So there's that piece. Derivative of 5x would be 5, and derivative of 5 would be 0. And we want to find dy dx. So a couple ways that you could approach this. The math teacher way is probably going to solve for dy dx first and then plug in. But you could plug in 1, 1 right now. Plug in 1 for x, 1 for y. And that actually might be the easier way to go. Math teachers like to do the algebra way. So, although for this one it really would be smarter to plug in now. So I've talked myself into plugging it in now. So x is 1, y is 1. That's kind of nice. That way if I get things backwards, it won't matter. So 1 over 1 times 1. Most of you would not write all these ones. You'd you'd know where you could leave them out. So let's see. Most of those ones don't mean much. dy dx plus 6 equals 0. So dy dx equals negative 6, at least at 1, 1 anyway. So that would mean the slope of a tangent line at 1, 1 would be negative 6. Questions on that one? So a little bit of implicit in there. So don't forget, whenever a y shows up, dy dx shows up. Number 2, find the derivative if f of x equals this. Maybe you could do this one in place. Maybe you want to show the work. F prime would be 1. G prime would be e to the 4x times 4. So this is pretty straightforward, I think. First times derivative of the second. So that would be 4x e to the 4x plus the other way around, x e to the 4x just checking to make sure that's correct. X 4e to the 4x plus e to the, whoops, I messed something up. I don't need an x on that last one, because maybe I didn't label my f and g clearly enough there. So check this again. First one is x times derivative of the second one. Okay. Plus the other way around, 1 times e to the 4x. All right, I feel better about that now. That one was pretty straightforward. That's almost certainly a multiple choice type question, which means they would do a little bit of work to clean it up. But that's an easy cleanup job. You would make it from there to there, I think, without difficulty. Easy for me to say. All right, last one, find a tangent line. Okay, so derivative and then a point. We've got the point. So I need a derivative, and then I'll use the slope and the point to write the tangent line. So f prime be 3 e to the negative 2x times negative 2, the chain rule. So that would be negative 6 e to the negative 2x. If I plug in 0, negative 6 e to the 0, e to 0 is 1, so my slope is just negative 6. Because the derivative tells me the slope at a point, or the slope of the tangent line. So y minus 3 equals negative 6 times x minus 0. Obviously, you don't need to leave the x minus 0, or you don't have the minus 0 in there, that's fine. Some of you, a few of you, are still solving for y, which is okay. But you risk, if you move the 3 over the wrong way, or you distribute wrong, you do something really silly, you're going to lose a point or two when you probably should have just left it alone right there. But if it bothers you and you need to see this for whatever reason, then you can get there. And it's not hard to get there. I just don't want you to make a dumb mistake and lose a point that you're risking a point that you don't even need to risk, I guess. It's the easiest way to say that. All right, that's it for review questions that I have. I have a review, kind of an optional review worksheet I'll give you in a minute. Let's talk about test outline. Then I'll give you the review. I'll post the answers later, and then we'll be done. Yeah, we're good on time. So 6 free response questions. Put that where you can see it there. 6 free response questions. All finding derivatives. Actually, I'll just spell it out. Because some of them some of them ask for dy dx or y prime or f prime, but that all means the same thing. Find the derivative. 4 of those I would call fairly straightforward using our rules of e and natural log. One of them is an inverse. So that's where you set up the table and just keep track of who's where and find your answer and flip it over. And one of them involves some implicit. We saw that in one of the warm-ups we just did, where the dy dx shows up kind of on its own. And then 9 multiple choice questions. A variety, some with e's and natural log, some with just old school quotient rule, product rule, trig, a variety of stuff thrown in there. 2 of them involve inverses. One of those is similar to the free response inverse, where you just kind of have to work the problem. Another one is it kind of gives you all the information. And I think if you'll make the table, instead of you having to find all the information, it gives you everything to fill out the table. It's just, can you make sense of what I'm giving you, put it in the table correctly, and then answer the question. So if you understand what I'm giving you, I think it's easier than doing the whole thing. It's just, do you know that if f of 2 equals 5, that means there's a point 2,5. And that would also mean that the inverse at 5 is 2. And then you could play with the derivatives and reciprocals and all that. So one of those multiple choice questions, I think if you understand what's being given, it won't take long. There's not a lot of computations to do. It's really just recognizing what am I giving you and how do you make sense of it? What derivative do I give you? How are they related? That sort of stuff. All right, so I think you'll have plenty of time. I'm going to pass out a review. I'll post it online with an answer as well. And again, tomorrow, don't look for anything online. I don't think I'm going to post anything extra. It's just your day to finish up and get ready. Let me see what should be due, though. That goes back the last 9 weeks. So we had page 325. We had page 352. And we had the worksheet from yesterday. Worksheet derivatives of inverse functions. And today you're going to get a review worksheet. Let's say that 2 of the 4 are due. Especially since the previous 2 were from the last 9 weeks. That's been like 2 weeks at this point. So if you've lost those or those are gone, so be it. You can get by with the 2 from this 9 weeks. I would say that in order to do well on the test, you better understand 3 of the 4, because these 3 are the new material. And then the review, obviously, is the review. Questions on any of that? So 2 of the things are due, which for probably most of you will just be the 2 most recent worksheets, and that's completely okay.